We're going to go over the solutions to some of the challenges from our airport traffic map dashboard workshop that we taught a couple days ago at the New York City Analytics Exchange. We'd like to thank Oliver of the Mayor's Office of Data Analytics and the rest of the team there for letting us teach this workshop. Most of our experience is in building web-based decision support tools for electricity infrastructure planning. We've done stuff for microgrids, for electrification plans, outage tracking, as well as some report automation that we're going to go over today. Right now we're making some step-by-step guides for flood and hurricane mitigation planning. And we want to help local vendors like pole manufacturers and tree cutters and battery energy storage vendors to be able to help their communities finish these projects. We need some help testing these guides. So we have some experience, please contact us. Our analytics automation framework is an open source package that turns your script or notebook into a web-based tool, report, or dashboard. So the main use is if you want to update your analytics widget fairly frequently without having to wait for the engineers of the parent web app to redeploy everything. So the challenges, the workshop is split into 4 parts. At the first part, you'll be mapping out the districts, and then we'll add a chart, add some real data, and then embed it. So after the first phase, you'll end up with a map that looks something like this, that updates every couple of seconds with random colors. We'll add a chart, and combine them with some real data using the Google Distance Matrix API. You do want to be careful what you save in your output variables because that's what people who have access to the dashboard who have access to that data. So now I'll go over how you can access the actual interactive part of the workshop. Go to docs.crosscompute.com, click on Automation Framework, Tutorials, Airport Traffic. And if you scroll down, you see this link that says Work Through This Tutorial Online. I'm going to click it. I'm going to set the session duration to 30 minutes. I'm going to use a Google key. This Google key isn't going to work for you. You have to get your own and enable the Distance Matrix API that I'll show you how to do later. I'm going to copy this password, paste it. And this is the Jupyter Lab interface, if you haven't seen it before. We have the file folder structure on the left, the workspace in the middle, and some panel extensions on the right. I'm going to make this a little bigger. So first I open Setup IPMB. I'm going to install the packages we're going to need for this tutorial. Our open source package is made of 4 parts: the core package, the Jupyter Lab extension, as well as the map extensions, and one so you could save your reports as PDF. Let's go into the phase 1 folder, double click. So if I open the panel on the right, so this first phase kind of shows you how to set up the automation to map the districts. Most automations you will need the config file, as well as some of them have scripts and some of your automations will have styles and templates. The config file tells CrossCompute how to run your script. You specify what kind of input variables your script takes, what output variables you want in your dashboard or report, any markdown templates, as well as what different sets of input variable values you want to run on. These are batches, the scripts you want to run, some things in the environment, such as, for example, how often this dashboard will update. Every 10 seconds it'll rerun this script, and some styling information. You can see the complete list of the configuration options in the configuration template. So let's quick launch to run and preview what the server looks like. So you see we've mapped our districts, we've added a random color. It updates every 10 seconds. This development server is live, so let's say if I change the name, it'll re-update this dashboard with the updated name. These batches tell the different kind of input variable sets to run your script over. So here we've only defined one row. These are the input variables, so we could have multiple rows for different types of configurations of the input variables you want to run. For this one, we're interested in mapping the districts that are this URL and calculating the travel times to JFK by public transit. Okay, so now let's go over the script. So what happens in the script? It downloads the the GeoJSON that's at this URL. It simplifies the files, and it assigns a random value of t to each district. So I'm using Shift-Enter to run it. You can see there are 71 community districts. So let's go over the exercises. Okay, so the first exercise, set simplification tolerance to 0.1 and observe how the map changes. Okay, so you see how this is how it looks right now. I'm going to change the simplification tolerance to 0.1. Relaunch. And we might need to delete the cached versions if you already ran it. So let me delete this data set. Let's see what the error was. No such file or directory. Datasets batch. Oops, I probably deleted too much. So let's recreate that batch file. Paste. Okay, stop. Launch. Alright, so we simplified the geometries 0.1. Those units are whatever units the geometries were in, which is latitude, longitude. So you can see 0.1 is a bit too much simplification. Change the color map from blue, red to green, yellow. Okay, so I'm going to open the config file. So the way this map works is we're using this expression. This is a standard mapbox expression. So you can see more documentation about it here. This lets us set the fill color of each polygon based on the value of the variable t. So we're saying get the value of t, and if it's closer to 1, show blue, and closer to 60, show red. So I'm going to change this to green, yellow. And you can see it's changed to green, yellow. Define a new variable called x that is random from 0 to 100. Change the color map to vary from 0 to 100. Okay, so I'm going to add a new variable. X, and change the color map to vary from 0 to 100. So I'm going to get the value of x, change from 0 to 100. And restart the server. So in each of the features, you can see that there's two properties now, T and X. Replace community districts with fire divisions. So let's take a look at the different types of districts we could be using. So we're using originally these community districts. We're going to replace them with the fire divisions to the GeoJSON, Melbourne, the batches file. Replace it with the fire district, save it. So now you can see how it looks different. So the fire districts, there's a lot fewer of them. Okay, now we're going to go over the exercises from phase 2. Phase 2, we're adding a chart. We add the colors using the bins. So we have a color map, it's a function. It takes a value from 0 to 1. So 0 or blue, RGB, and 1. Let's change the color map from blue, red to green, yellow for the chart. Blue, red, green, yellow. The chart. use a new variable called x that is random from 0 to 100. Let's make it x 0 to 100. And a reference time 0 to 100. Each bin is kind of the bucket for that part of the histogram. Compute the centers for the color value, and we normalize each of the centers so that they vary from 0 to 1 by dividing by the maximum value that they could each have. So that's where we get our color indices. Go into the final phase, phase 3. This is where we're adding the real data. So it will look something like this using the Google Distance Matrix API. You do want to change your interval from 10 seconds to something larger. The way we compute it is we calculate the representative point of each district. We looked into some alternate ways to do it, such as by computing the random points in each geometry or getting grid points, but in the end decided on representative point. Just so you know what representative point is, it's a point in the geometry that's guaranteed to be within the geometry. So, for example, if you have a donut with a hole in the middle, calculating the centroid is not going to be within the donut. It's going to be in the hole. So representative point will be guaranteed to be within that geometry. So the challenge here in phase 3 is to find the polygons for which the representative point is different from the centroid. See something surprising? That they're all of the representative points are different from the centroid. Notice that they only differ by a couple of decimals. So let's look at the ones where the distance is far off. GeoPy in here. Okay, and let's use units of meters. 209 meters. Here you can see the centroid is outside of the polygon. Alright, so we're going to add an iframe. So there you have it, an embedded. When you want to automate your deployment, use deploy keys for your repository. That way, when you commit to your repository, it'll update your widget automatically if you commit to a certain branch. And also, you can use this Frame Ancestors content security policy if you want to prevent your widget from being embedded by other sites that you don't approve of.